Hello everyone. This video is my submission for the Creative Challenge in the online AI planning course of the University of Edinburgh. The topic of this talk is AI planning in speech interaction systems, and my name is Guido Gallipan. Let me quickly introduce myself. I got my master's in electronic engineering from the University of Ghent in Belgium, and I have been working in research and development in many different areas. But since 1992, I have been working on technology and applications involving speech recognition and natural language understanding. As of 2001, I have been leading the Dragon Naturally Speaking Research and Development Organization, and currently I'm heading up healthcare research in Nuance. What are speech interaction systems? Well, speech interaction systems are where a human interacts with an automated system by voice, at least as one of the modalities. I just selected a few pictures of example speech interaction systems. You see PC dictation and voice commands, voice navigation in the car, medical dictation, speech synthesis, and virtual assistants. These systems use a combination of automatic speech recognition, speech synthesis, natural language understanding, machine learning, information retrieval, just to name a few. The most advanced of them use AI planning techniques in some form or another. I will cover two examples in this video. The first example is voice commands, a functionality of Dragon Naturally Speaking. This is about controlling a PC with your voice. The system recognizes speech and produces a verbatim transcript of what was said. Then it analyzes the command phrase and creates a semantic representation that captures the meaning and the intent of the command phrase. And next, it determines how to put this command in action, and then it executes. Now, in the most simple cases, this does not involve AI planning at all. Consider phrases like file open, file new, that map directly to keyboard key sequence Control O or Control N. Here typically the ASR engine is very simple and only recognizes a fixed set of phrases, and the NLP and acting is as simple as a table lookup and sending the right keystrokes to an application. But such systems are very limited, and users have to memorize an allowable command set. Much more complex systems exist that provide a much broader command set and that eliminate the need for memorization. From an AI planning perspective, once the intent of the command has been recognized, this becomes the action for which the action plan needs to be found. Now consider the command phrase, move the first two words in the sentence to the last paragraph. This phrase has a much more natural command language, and a much broader and complex functionality. Let's see what is involved to execute such a voice command. So after the speech recognizer has produced a transcript of the command utterance, there is the natural language understanding. And first, the recognized command phrase is parsed with the help of context-free grammars that cover the application. This produces a parse tree that represents the syntactical structure of the phrase. And second, there is the semantic interpretation, where the specific words in the parse tree are mapped to semantic units that have meaning in this domain. The syntactic tree structure is mapped to an expression similar to a logical tree that you can see on this slide. In essence, the expression here says that we want to move an object to a certain location, and that the object is being a quantifier applied to a set. So the first two elements in a set of words that was formed by this sentence, and the location is the last paragraph, or the last in a set of paragraphs. Next, we are doing the action planning in the domain of text processing, where the types of the domain are the cursor, the characters, the words, the paragraphs, sentences, selections, and so on. The predicates of this domain are many as well. But for example, we have part of relationship that we use to check containment, like part of word sentence is true and part of sentence word is false. The operators are in essence the function in the text processing API to edit text, enrich text. The goal is to find the right ground actions and the right sequence to perform the actions stated in the logical form on the previous slide. And we use a system that applies rewrite rules to iteratively construct a plan that in this example takes the form as shown here. So we are first putting the cursor in the start of the sentence, then we select the next two words, then we cut, then we go to the end of the section, we go to the previous paragraph, and we paste. The last step is to generate Visual Basic script code according to this action plan, and that we execute via automation. Note that response time for command and control need to be less than half a second. That is for speech recognition, natural language understanding, and planning combined. The next example in AI planning are dialogue systems. Dialogue systems interact with users via speech, typically over the phone. They have automatic speech recognition, speech synthesis, natural language understanding, natural language generation, and dialogue management. The advances in ASR technology are allowing mixed initiative dialogue strategies where the user can initiate the dialogue and the system needs to respond appropriately. This increases the range of system responses and the requirements on the response quality in terms of informativeness and adaptation to the context, and it also raises the bar on technology and user interaction design. The relevant AI technology here are intelligent agents, and intelligent agents are autonomous entities that perceive the world and act toward achieving goals. This is a large AI topic, and by the way is also covered in the textbooks that we have from Russell and Norvig. Let's take a quick look of what is involved. On this slide you see the architecture of an agent, and the arrows represent processes and the boxes represent knowledge in some knowledge representation form. Perception is the process through which an agent perceives the world, and beliefs is the representation of the agent of the current state of the world. Desires, the agent should have a positive and negative responses to various states in the world and a way to compare the desirability of the states. Planning is the process to reason about ways to attain other belief states. And commitment is the process to decide to act to get to a different state. Finally, intentions represent the course of action that is decided upon, and acting is the process to act and thus change the state of the agent and the world. In this model, beliefs, desires, and intention are part of the agent's cognitive state. Hence, we call that the BDI model. And the planning process creates a belief in the agent's cognitive state that it knows a plan to reach a certain goal or perform a certain action. An agent can know many plans as part of his beliefs. It is only by the process of commitment that one of the plans becomes an intent, for which the agent will act by executing the chosen plan. Now, in the case of dialogue systems, we have conversational agents that are agents that can participate fully in a natural dialogue and where perception and acting involves natural language and speech. Planning of what to do next is the core process in this system. I will give an example of communicative acts and natural language generation. In essence, there are three phases. Text planning is about finding a sequence of atomic communicative goals that accomplish a high-level communicative goal. Atomic goals can be attained by uttering a single clause. Sentence planning chooses the lexemes, that are abstract forms of words, to be used in the phrases and grammatical relations between them. And in the realization, the final textual form of the utterance is constructed before it sends it to a speech synthesizer where it is vocalized. On the right, you see an example in detail. So, this concludes my talk about the use of AI planning techniques in speech interaction systems. And we have seen that in advanced systems, their use is deep and plentiful. Before we end, I would like to point you to the following URLs that demonstrate a well-functioning voice interaction system and a not so well working system, which I was told may have been recorded in Edinburgh. I hope you find the talk interesting, and I look forward to your comments.